Okay, this is part 1.1b, so the second part of section 1, and we're going to pick up with where it says list all the counting numbers from 1 to 100. I'm not actually going to have you do that, but I just want you to think about what it would take to actually list those first 100 numbers. Then if I ask you, well, you could do it, but it'd take a while. Then if I ask you to list all the numbers from 1 to 100 and include all the decimals, the fractions, all the rational, irrational numbers, that's impossible to do. You can't physically write every single number between 1 and 100 that includes all the rational and irrational numbers. So we need a way to represent all the numbers between 1 and 100, rational and irrational. So we can do that with set notation. And the first, there's three different set notations I want to talk about. The first one is roster notation. And if you think of a roster, if you play sports, you know that your coach has to turn in a roster, which includes all of the players' names. And if they don't list everything, then they get in trouble. They could forfeit a game. So think of a roster as just listing all the elements in the set. So all of the elements of the set are listed in between braces. There are commas in between, and they can only be used on an infinite set or sets where a pattern can be understood. Okay, let me give you an example. If I ask you to list the set of whole numbers, and I'm underlining whole because that's different than natural numbers, up to and including 5 in roster notation, we can do that. That's a finite set and it's very small. So I'm going to list the braces first, and then I'm going to write, oh, in the 0 you can't see very well here. There are braces at the beginning and the end, and then we start at 0 because of the whole number. Now if it said had natural numbers, then we would not have that 0 in there. So it's just 0, 1, 2, 3, 4, 5 with commas in between. If I ask you to list the set of whole numbers, you could say 0, 1, 2, 3, and then we could keep going dot, dot, dot. Interval notation is different than roster notation. Interval notation is used to represent a set of numbers between two endpoints, and I'm going to use that kind of loosely because sometimes the endpoints are not included. This includes all the decimals, fractions, rational and irrational numbers between the two endpoints, and they may only be used with an infinite set of numbers. So we couldn't use interval notation with something like this because that's a finite set of numbers. It has to be infinite. It's used with numbers represented by an inequality or a number line. So think of it as all the numbers between two numbers on a number line, or including, depending on how it's written. The symbols used in interval notation are a left and right parentheses or a left and right bracket. And it could be any combination of two of them. It could be a parenthesis with a bracket. That's okay. Okay, so let me give you a couple of examples here. On the left, it says if you do not want to include the number, use the left parenthesis or the right parenthesis. This symbol corresponds with the inequalities less than and greater than, or the open circle on a number line. So here is the number line, and I did a snip, and it did not copy well, so I'm going to have you just write the numbers under here. This is a -1. There's a closed circle here and a -4, and it keeps going. So when it keeps going, it's going off into infinity. So I wrote the interval notation down here. I want you to pay attention. You need to list the smallest number on the left, the largest number on the right. Now when I say the smallest number, it keeps going off into infinity, and you can't stop infinity, so it can't be closed up. So it's going to be a parenthesis, so it means it's not included because it keeps on going, or it's not closed. And then the highest number goes to -1. Now because this is a closed circle, we have to use a bracket. If it was an open circle, we would use a parenthesis. So here it is, written over here, maybe a little easier to see. The highest number is 1, and it includes 1, and it goes off into negative infinity. All right, let's write it in roster. Try to write it. If you try to write it in roster notation, you can't do that because roster notation, we would have to list everything. We'd have to list the -1.5, -2.5, -2.67, and so on. So roster notation you cannot do. Okay, whenever you have positive or negative infinity, you're always going to use one parenthesis with it, just like I did right here. All right, let's look at another one here, and this one again I used a snip and it didn't copy very well, so I'm going to have you write this on your paper. This is what the actual inequality or the statement was. Now, because there's an or, that kind of breaks it up. We're going to write two different interval notations. So if you look at this, x is less than 2. On a number line, it looks like this. So this goes off the smallest number, I guess not really smallest number, but you want to think of as negative infinity is where it's, it's going off to negative infinity. And then the highest number is 2. So that's going to be the first part of our interval. And then the next interval is in between 3 and 11. It includes 11, but it does not include 3. So let's look at that. So here is the representation for interval notation for the first one. Infinity is, I'm going to in quotes, the small number. You can't put a bracket on infinity, so that's a parenthesis. It does include 2 because there's a closed circle, so this represents a closed circle. Then we're going to write it in roster notation, and again, we cannot do that because we can't list all of the decimals and all the fractions in between. We can't physically write them down. Okay, so that's interval notation, and just remember, if you have a closed circle, you're going to use either the left or the right. If you have an open circle, you're going to use the parentheses. Brackets for closed circle, parentheses for open circle, or these inequalities that go with them. All right, last set we're going to talk about is set builder notation. And set builder notation sometimes is just called set notation. And it uses the properties of elements in the set to define the set. The inequalities, these are the inequalities that you would use: less than, greater than, less than or equal to, greater than, equal to, not equal to. And it uses the element symbol. Now this, I'm not sure if you can make it out real well on this video, but it looks like a C with a line right here. It's not like a E that has hard corners. So those are often used in set builder notation. And if your set refers to real numbers, you do not need to use the element symbol. And I'll explain that in an example down below. All right, so let's look here. You can think of a set builder as having 4 parts, set builder notation. And again, another bad snip. I'll have to fix those when I do my next video, get a little bit better quality of snip. Okay, so when I say 4 parts, what I'm talking about, you need the braces, that's in green. You need the set of all x such that. That's what that reads, the set of all numbers x such that. And that's in pink here. And then you need a description. You need to define the range, or say the highest or lowest values, or what numbers are involved, or what are you talking about. And then you have to say, are they natural numbers? Are they whole numbers? Are they integers? And the only time you don't have to do that is if you're talking about every single number on the number line that would be in between those 2 numbers. So if they're real numbers. So I just put and x as an element, and I'll put a blank here, if needed. All right, let's do an example here. The first thing that we're going to do is we're going to try to write it in interval notation. Now, interval notation, if you remember from before, represents an infinite number of values in between the 2 numbers, because it's every number on the number line, all the decimals, all the fractions that are in between the 2 endpoints. So this cannot be written in interval notation. Now, if you thought that it could, and you thought it should look like this, then what you're saying is it's going to include 0, it's going to include 0.1, 0.2, 0.3, 0.4, 0.5, blah, 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 all the numbers in between. And that's not what we're talking about. We're only talking about those 3 numbers. The next one is roster notation. Can we list that? Remember, roster is a list. Can we list the elements of the set? Well, this basically is roster notation. So all we had to do was recopy that. And now we're going to write in set builder notation. So we have to start out with the brace, write the set of all numbers x such that. So we're just saying we're going to use x to represent the numbers. And that's the first part you need. And then you have to say what values you're talking about, because if you don't, then it's every number on the number line. So we are in between 0 and 2, which means we're going to put an inequality here and say x is in between those 2 values. And it does include 0, it does include 2. So we're going to put a less than or equal to here, greater than, x is greater than or equal to, because I'm reading it from right to left instead of left to right. This reads x is greater than or equal to 0. Now, I don't want the decimals, I don't want the fractions, so I also have to say, and x is an element. Now, do I want the natural numbers or the whole numbers? Well, because I'm including 0, it's going to be the whole numbers. X is an element, the whole numbers, and then I close the parentheses. Okay, another example here is a number line, and I think you can read the numbers on this snip here. Write an interval notation. Now we want all of the numbers in between, so we can write an interval notation. So interval notation has, you can kind of think of 4 parts, I guess, or if you want to count the comma, that would be 5. You have the 2 endpoints with a comma in between, so we have 1 and 5. And then you have to have either parentheses or brackets. Since these circles are closed, this shows that we want to include those 2 numbers. Now, if it had been written like this, with the 1 here and the 5 here, we would still use 1 and 5. We would use a parentheses because we're not including 5, and we would use a bracket because we are. So you can have a mixture of brackets and braces, or sorry, of brackets and parentheses. It doesn't always have to be a matching set. All right, roster notation. Can we list all of those, everything in between? Well, no, because we would be listing on the number line. Remember, it's not just the numbers that you see here, but it's every single thing in between. So 2.3, 2.5, 2.7, and so on. So with roster notation, we would not be able to do that. All right, now let's try set builder notation. Again, you need to do those 4 parts and maybe the 4th one if it's needed. So we're going to start out same way every single time. We're going to use the brace, and then we're going to say the set of all numbers x such that. That's what that means. So it's a lot easier to write x with a bar than to write out the set of all numbers x such that. Okay, now x is going to be in between 1 and 5. So that's how we're going to write it. And it does include 1 and 5, so it's less than or equal to 5, greater than or equal to. Now this looks like a less than sign, but I'm reading it this way. X is greater than or equal to 1. This is a compound inequality, and that's how you need to write that. So we put that in here, and now we need to decide if we're talking about every single number in between here. Are we including everything, or do we have to exclude some things? We do want all the decimals and all the fractions in between, so we know that we're talking about the real number system. So we can just close that right-hand side with a brace. Now you can write it like this, and x is an element of the real number system, but you really don't need to, so I won't mark that down. Okay, that's it for your second video, and here's your practice problems.